Good day everyone. In this tutorial video I'm going to be covering a question from workshop 2, in particular question 4, in which you're given a set of set of data which is comprised of two different variables, x and y, and from that you need to find what they call, as we can see is the first question, we need to find the covariance, and then from the covariance we can then find what's known as the correlation coefficient. And from that we can then talk about the nature of the relationship between x and y, whether or not a relationship seems to exist or not. Okay, so the first thing that we'll do is just go over a few formulas. We'll go through explaining some of the formulas, decryptifying some of the mathematical notation, and then we'll go through and breaking it down into a tabular form to find the covariance. So I've transferred it over onto another document because I think it's better laid out this way, and I think it goes much easier with the formulas that you're going to see. The formula for the covariance between two data sets, x and y, and firstly, before we go any further, x and y both have to be numerical. The covariance is a measure on numerical variables. So we couldn't do the covariance between a categorical variable and a numerical, or a categorical and a categorical. This exists purely for a numerical versus a numerical situation. So yes, the covariance of x and y is equal to this nasty thing. So before we have a look at the numerator, let's have a look at the denominator. The denominator is by far the easiest component, and that's just n minus 1. So the reason why we have n minus 1 is because this is the sample covariance. So in the question, and I should have mentioned this first, you'll see that it says it's sample data. So as I mentioned in previous videos, when we calculate certain parameters and statistics based upon sample data, it's done in a slightly different manner than if we're dealing with population data. So you'll probably see a formula for the covariance that's very similar to this. However, you'll see it'll be divided by n as opposed to n minus 1. The n minus 1 is because it's the sample. Sorry to repeat myself. Okay, so let's have a look at what's on the numerator. So we've got this ugly term. Now the first thing, going from left to right, is we have this symbol, and this symbol is the Greek letter sigma, and it refers to, or it translates in terms mathematically, to the sum of. So where you see that symbol, you can replace it in your head with the sum of. So this is the sum of this expression. So we have two brackets, and so let's have a look at each component within each bracket. xi refers to the data element xi. So, and that was a poor explanation. That refers to the ith element in x. So what I mean by that is this is the variable x, which is this data point. These data points. xi refer to the individual data points. So for instance, x1 would be 8, x2 would be 16, x3 would be 18, and so on and so on. So where we see xi, that just refers to the x data element I, or the ith element of x is probably a better way of saying it. Similarly for yi, that refers to the ith element of y. So y1 would be 30, y2 would be 26, y3 would be 23, and so on and so on. X bar and y bar should be something that you've seen before. They refer to the sample average. So x bar is the sample average for x, and y bar is the sample average for y. So before we can compute anything to do with the covariance, the first thing we need to do is find out what the sample average for x is and what the sample average for y is. And to do that, we see that this formula may look very, very complicated in comparison to the formulas that you've seen for the average before. But in order to compute the average, we just take the sum of all of the data values, and then we divide it by the number of data points. So in this case, that would be, for x, we have 8 plus 16, oops, I'm not sure why that's, oh yeah, here we go, plus 18 plus 21 plus 22, divided by, and the number of elements is 1, 2, 3, 4, 5. So that's equal to 85 divided by 5, which is equal to 17. I believe that's correct. And then similarly for calculating the sample average for y, this becomes 30 plus 26 plus 23 plus 20 plus 11. So that's 30 and 26 is 56. 56, 79, 99, so that's 110 divided by 5, which is equal to 22. So now we've got x bar and we've got y bar. So we've got this component of the formula and then this component of the formula. So when we have these complicated expressions, generally the easiest way to do it, especially if you're going to do it by hand, is to break it apart into easier operations. So before we apply this sigma operator, the sum of, let's just compute what it wants us to take the sum of. So what it wants us to take the sum of is, for each value of x, subtract away its mean, and for each value of y, subtract away its mean, and then multiply those two values together. And so that's what we see represented in these two columns. So this column will refer to each value within here. We are going to subtract away the sample average for x. So that will be equal to 8 minus 17. Remember that our sample average is 17, which is equal to -9. And repeating it for the same, so this will be 16 minus 17, which is equal to -1. The next one will be 18 minus 17, which is equal to 1. 21 minus 17, which is equal to 4. And then lastly, 22 equals 22 minus 17, which is equal to 5. So we need to do the same for the y. So for each value within this y column, we're going to subtract away the average for y, or the sample average for y, I should say. So we're going to subtract 22 away from each of the values. So let's do that. So that's equal to 30 minus 22, which is equal to 8. Going down, we have 26 minus 22, which is equal to 4. The next one is 23 minus 22, which is equal to 1. And the next one is 20 minus 22, which is equal to -2. And then lastly, we have 11 minus 22, which is equal to -11. So, in terms of this formula here, what we've, what we found is, excuse me, for each of the data points, we've subtracted away x. For each of the y data points, we've subtracted away y. Sorry, I know I said that in a very convoluted fashion. Let me start again. For each element within the data set x, i.e. xi, we've subtracted the sample average for x away. So, i.e. we've taken each value within here and we've subtracted away the sample average for x, and we've done the same for y. So you'll notice that we've put those things into separate brackets, and we notice that the brackets are side by side. So how that translates in terms of mathematical representation is, wherever you see that, that just refers to the two values being multiplied together. So this column here, which refers to what we have in this sum, is simply just this column multiplied by that column. So we'll do that now. So that equals -9 times by 8, which is equal to -72. The next one will be -1 times by 4, which is equal to -4. Going down, we have 1 times by 1, which is equal to 1. The next one is 4 times by 2, which is equal to 8. And then lastly, we have 5 times by -11, which is equal to -55. Okay, so if we have a look at what we've got here now, we've now computed this component of the sum for each of the values. So the next thing that we need to do is we need to apply, we need to apply this operator, which is the sum of operator. So by the sum of operator, we want to take the sum of all of these values. And so I'm just not sure about doing that in my head, so I'm going to get the calculator to help me. So -72 plus -4 plus 1 plus 8 plus -55, and so that comes to -122. So therefore what we have within here is this becomes equal to -122, and then that's divided by n minus 1, which is 5 minus 1. So that's -122 divided by 4, which equals, so we'll just do this over here, divide by 4, and we get -30.5. -30.5. So that's the covariance. So that is part A. We have found the sample covariance between x and y. So the next thing that we need to do is we need to compute by hand, the correlation coefficient R. So I'll just give you a little bit of a background into